Piotr Żelasko, Head of Research at Meaning. The website is meaning.team, and it is a stealth startup working in speech technologies. And full disclosure, I am an advisor to Meaning. But our objective in this episode is to get you all excited about speech. And we're going to do that in two ways. First, we're recording this on the same week that OpenAI released a system called Whisper. So we'll talk a little bit about Whisper. But also, we will talk about a set of open source projects that Piotr is involved with, which we have written about. And they are projects that will allow all of you to get started with speech, primarily processing speech and audio data. And I will link to that well-received post in the episode notes. So, Piotr Żelasko, welcome to the Data Exchange podcast.
Hi, Ben. I'm very excited to be here.
So, first, let's talk about this system from OpenAI called Whisper. So, if the listeners are not familiar, OpenAI released this speech recognition system. Open source code is available. Paper has been published detailing what they did, but it has a couple of characteristics. And Piotr, you're the expert, so I will defer to you. But one, it's trained on massive amounts of data relative to previous systems, and secondly, it's an end-to-end system. So, Piotr, very quickly, and we'll dive into more detail. So,
all right, perfect.
So first of all, speech recognition itself, it is fair to say, is the probably most popular use case for speech, right?
Yeah, I guess you could say that. People have been working on it since the 50s of the last century. Only started getting interesting results, like I would say 30 years ago, and really good results like 10.
And for our listeners, speech recognition in practical terms means taking speech and turning it into a transcript.
Exactly. It's basically trying to write down whatever you said.
And so then there has been, so I think we may have noted this in our post actually, that when people think of deep learnings for surgeons, they think of computer vision, but in reality, speech was right there. So it's not new that deep learning has been used in speech, and DeepMind has had a good system out there for a couple of years. So what catches your eye about Whisper?
All right. Well, the biggest thing about that paper and that work, they used a massive amount of data, basically an amount of data that was, I would say, unheard of in the speech research community before.
So prior to this system, what was the largest amount of data, and how would you relate this? Is this like 50x larger than the previous system?
So the typical size of data in industry papers, I would say it's 50,000 hours. I've seen weekly labeled data around 100,000 hours. They gathered 680,000. That's, if you count this in years, that's a lifetime of listening. It's 77 years of listening nonstop.
So how did they do this? So how did they create this data set?
Oh, this is a question that's right now on everybody's asking that. They say they got the data from the internet, basically by web scraping. And they're not the first. They have been several projects that did it, like even 30, 50,000 hours of data gathered this way. But what really gets my attention here is the amount of engineering that went into their data pipeline. How to curate this data, how to ensure the quality, how to get different types of labels. They got timestamps for words, for example. You don't have that in the internet. You have to create them. And they haven't said a lot about it. They gave a brief description.
So, but basically, anyone who listens to podcasts has probably noticed that some podcasts consistently for every episode will publish the audio and the transcript. So,
That's right.
so besides podcasts, I guess YouTube also has transcripts, right?
Yeah, I think some of them are even like human created. Most of them are created automatically with Google's ASR. But yeah, YouTube or other platforms like that. I guess in the older days, people used to self-host some of those things and like put some content. There is a huge project called LibriVox. People just record as they read audiobooks. There's actually a lot of
audiobooks as well. Audiobooks.
Yeah, there's a lot of data, and it's Creative Commons. It's CC0, I think. It's basically the public domain. You can do like a lot of things with that data.
But as many people know, if you crawl the entire web, there's no uniform standard for the quality of the data set, the format, and so on and so forth.
Yeah.
So if you speculate, so how do they create such a uniform data set?
Wow, that's that's a killer question, really. But I would imagine they have to have some sort of a bunch of models, but maybe some ASR model, maybe some segmentation model, voice activity detection model, alignment model. For example, you often want to know if we talk for 1 hour right now, right? You cannot just take that 1 hour, give it to the model to learn from. You have to cut it into some smaller pieces, like maybe sentences, right? So one way to do it is to do it manually. Another way is to build some sort of model. And I believe that's what they have to do.
They hint at 30-second windows, I think, right?
Yes. They said about the number 30 seconds. I saw that number in other works before. It seems to be like around the limit of how much data it makes sense to present to the model in training in one point in time.
So this is actually a prime example that of that rule of thumb where most of the work goes into the data.
Oh, definitely.
Right.
Definitely. If you look at their paper, this is very interesting, actually. They have shown, they took Transformer from 2017 with little modification, really, and they just scaled the model up and they scaled the data up. There is no like specific speech modeling tweaks, or not too many, I would say, in their work. They have shown that it is really about data, and if you can get that data, if you can curate that data, you will see amazing outcomes.
So then, so with speech, so I think computer vision, NLP, our listeners have either played around with it or actually have hands-on day-to-day experience with it. But with speech data, I have 680,000 hours of audio plus accompanying transcript. So in reality, you have two sets of data, right? So a lot of audio, a lot of text. So then you're gonna have to, and then you train a model. So this is not self-supervised. This is supervised, right?
This is supervised. Actually, yes, that is another thing they did kind of against the hot trend. It's maybe some people call it weakly supervised because some of those transcripts or many of those are actually not entirely accurate. They might have mistranscriptions, repeated words, not exactly matching content. But still, they have shown even with that, you can achieve really competitive results across a lot of benchmarks.
So what is the translation angle of this model? So in other words, I'm assuming most of their data is in English. And then what happens in terms of translation?
All right, this is actually a very exciting mechanism, like contribution that they did here. I will step back a little bit to answer this question. If for those who listen and are familiar with NLP models, I'm sure they must have heard about the model called T5, which basically was trained in a multitask way. You tell the model what you want it to do, the model reads it, the decoder of that model reads it, and it does whatever is supposed to be the task. And this is the mechanism that they ported into Whisper. They actually tell the model, okay, tell me what's the transcription of that piece of audio in English, even though somebody is speaking in a different language. And apparently they found data in the internet to support this. Like, for example, I am aware of Parliament sessions recordings for different countries, like in a European Union, for example. Every EU Council session is translated to all the EU languages, right? So you have this kind of parallel data. I can't speculate what they have, but I can see how they can leverage that kind of data to achieve that.
But then the majority of data is in English.
Yes.
So to do this translation step well, they have to have also a lot of data for each language.
That's true. That's true. I don't remember the exact numbers. I think it was about 70 or 80% English. The rest was other languages. That's still a lot of data. That's like 100,000 hours or so.
Yeah. So end-to-end models are kind of like this holy grail in speech. So for our audience who are not familiar, what is this notion of end-to-end? And I guess most people will just think there's only one model involved. But in reality, in the past, there was a sequence of models, right?
Yeah, I am laughing here because within the speech community, actually, the term end-to-end is not very well defined. I would say the definition changes with time. Like around 2006, people thought end-to-end means you don't need to have a phonetic dictionary, right? You don't try to transcribe the phonetic units, you transcribe the whatever letters you write. And then,
hold on there. So Piotr, for those of us who don't work in speech, in our mind, here's the recording, black box, transcript.
Yeah.
So the black box is only one model in our mind, but you're saying in the past that black box was a sequence.
Yeah, that's a great point. In the past, people tried to factorize the speech recognition problem into multiple models. You had an acoustic model that tried to model your basically what sounds are you emitting with your mouth. There was a lexicon, which is a phonetic dictionary, how you transcribe every word into phonetic units called phones. There was a language model that models the probability of how words tend to co-occur together.
And they're connected in a pipeline.
Exactly, and you put all of those models together, trained separately, by the way, into a single pipeline, and you hope that they kind of work together well.
And so then now, with this model, it's only one model does everything.
Oh yeah.
And is this unique to this model, or is this being done more broadly in speech recognition?
This is a more broad trend for the past, I don't know, 10 years, maybe more than that, actually. People are trying. Well, I think by now they convinced everybody end-to-end is the way to go. It wasn't so clear a few years ago.
But if people just interact with some random, well-known speech recognition system, what's the probability that's end-to-end?
That is such an interesting question. I would say.
I mean, how mainstream is it that? How mainstream is it that it's now being deployed in production?
Yeah, in the research, I think it's mostly end-to-end. In production, I am not entirely sure because there are a few issues like domain adaptation. Sometimes people speak very specific type of language, right? And unless you have a lot of data to represent that specific domain, it turns out sometimes it's better to take that hybrid system, not end-to-end generation. And it's much easier to find, for example, just text for some domains like, I don't know, medical domain. And then you have a way to influence how that system works more easily than an end-to-end system. But I really cannot say. There's been a lot of progress in the past few years on end-to-end, and I'm sure people are working on this problem.
So for a long-time speech person like you, a model like this is interesting for some of the reasons we described. But one thing I gather is this is not the kind of model that you would enter into a competition and expect to win a benchmark, right?
The end-to-end model.
No, Whisper.
Whisper.
Yeah.
Yes.
There are more. If you look at benchmarks, Whisper will probably lose, right?
Yeah, that's true. And the main reason, which is, by the way, claimed in the OpenAI paper, is that they claim people overfit to benchmarks. Basically, every benchmark has its own quirks, you know.
Right.
And if people train on data relevant for that benchmark, they tend to overfit, and their system doesn't generalize. And that's something Whisper is aiming to solve. It basically hasn't trained on any of those benchmarks, and it's tested on them, and it's still getting quite close results. And some of them, they're really impressive, actually. Some of them, it's a little bit behind, but it's understandable.
So if, let's say there's 25 respected benchmarks, I guess the competition should be reworked as to build a system that can do well in all 25 benchmarks, right?
Yeah, I think that's the way it's got, the direction it's heading right now. And
so with Whisper, 680,000 hours of data, of audio, and then the accompanying transcripts. So in the end, how big is the model? I mean, by big, I mean, because in language, you now start hearing about this, billions of parameters, right?
Yeah, that's right. It's definitely going into that range. I mean, past, yeah. I don't remember the exact number. It was definitely billions.
Oh, so Whisper itself is so big that to train a system like this, even if they give you all their data, would cost a tremendous amount of.
Yeah, that's actually, you're touching upon an interesting topic, the replicability of this study, right? Like right now, you don't only need to have a lot of GPUs and processing power, you also need to have the whole infrastructure, how to serve that 680,000 hours of data into your training pipeline. It's a non-trivial engineering feat. It's really impressive.
Yeah. And now I know that publicly, the OpenAI team have acknowledged that they use Ray. In full disclosure, I'm an advisor to Anyscale, the company behind Ray. But so for scaling their training, at least. So, but then when you get to inference, it's probably still a big model, right? So you'd have to put it in the cloud, right?
They have a smaller variants of this model, like Whisper Medium, Whisper Small, that actually, I believe they might be suitable for more local inference, maybe not necessarily CPU. But again, I believe there's a lot of optimization work going around that could actually make it run on device.
So one of the words that gets thrown in the context of Whisper is this word zero shot. Can you explain that term generally, and then explain it in the context of Whisper?
All right, of course. Typically, what I believe people understand by zero shot is the ability to generalize to new tasks for the model without ever seeing the data relevant for that task. In terms of how zero shot is defined for Whisper work, I would say it's maybe a little bit different definition, because technically the model learns ASR, right? It learns how to do ASR on a lot of data. The zero shot is in terms of the domain. For example, let's take switchboard benchmark. It's telephonic speech, 8 kilohertz, narrowband, conversational. There is a high chance this kind of data was maybe even never seen in training. There's not a lot of that kind of data available in the internet. And still Whisper is able to show, hey, it can transcribe it pretty well. Maybe not as good as top models for this benchmark, but pretty good job.
So, as someone who has a podcast who uploads the audio to a transcription service, I can tell you that it's good enough to peruse, but not good enough to release. Well, for a few reasons. One, the system makes mistakes. The system I'm using, I'm not going to name names. But, and then the secondly is that it's just the nature of how we talk, right? So we don't talk as perfectly as the way we write. So, so at what point, Piotr, do you think we'll have ASR systems that also rewrite so that it becomes more intelligible?
Okay, that's a great question, actually. There's a lot of factors in our speech that make it difficult for ASR to understand. So, obvious things like, hey, you can clearly hear my accent is not a US native accent, but the most data that's available for training ASR for English is actually native data. So I am at a disadvantage, right? The system is not able to transcribe me as well. One way to get there, well, it's of course to produce thousands of hours of Polish accented English data. But I think what's is quite promising and what OpenAI is showing with Whisper is that maybe, if you actually throw a lot of diversity that's out there, you might be getting much, much closer to some sort of system that's invariant towards those things like my specific pronunciation. Maybe I have a bad microphone, maybe, those kinds of things. This is a major issue for ASR today, I would say.
So is one of the clear takeaways here, Piotr, the unreasonable effectiveness of data is kind of validated in speech in the sense of if I have the right data set, I don't have to have the best model.
That's right. And just think how well you can get if you combine actually a very specific speech model with that amount of data.
And you anticipate that now, I guess I'm not sure. So if, let's say, for the sake of argument, OpenAI releases the data set.
Mm-hmm.
If that happens, then people will be able to build even better models, right?
Provided they have enough resources to actually train it, which is problematic today. I think there's generally a broad awareness that, for example, academia is a little bit left behind in terms of computational resources. I don't think this kind of scale can be replicated by many academics.
It's actually twofold, right? So there's the computational resources, and honestly, I think our podcast listeners have heard me say this. It's also lack of systems and distributed systems engineers.
Yeah,
because even if you have the computational resources, you still have to actually implement at scale, right? So.
Yep, and it's a different mindset. How do you those things? It's different how you work with 100 hours of data. It's different how you work with 500,000 hours of data, right? Completely different skill set.
So, speech in general. So we published this post around speech data processing, and here we are talking about how data is central to this new development in ASR, automatic speech recognition. So, but then in their case, Piotr, so distinguish the kinds of tools that we talked about in our post, for example, Lhotse, which allows you to do kind of like data science-y, data preparation, kinds of data pipelines with audio data, with what OpenAI basically just found data in a transcript and kind of did some alignment, but they did not need tools like Lhotse. So explain this for our audience. Well,
all
what
right.
is the role? What is the role of a tool like Lhotse that maybe gets deeper into the audio?
Okay. Okay. I love that question actually. This is interesting. I had one conversation about it yesterday, and they did not use Lhotse, I suppose, because they listed a lot of software they used. Lhotse was not there. But actually, Lhotse provides the kinds of features you would need to scale. I cannot say to that amount of data because honestly, I have
No, no,
never worked with so much.
even before you go
But
that deep,
yes,
so for us that don't work in speech, right? So my impression is you have audio, you have transcript, you kind
yeah,
of align the two. I don't know how you do that,
yeah,
honestly,
okay.
but then that's it. Whereas Lhotse is more intended to do what? It gets you into really deeply into the audio itself, right? So
That's correct. So the main motivation behind Lhotse is to kind of open up the world of audio data for people who maybe don't have as much experience, or maybe they are experienced, but it's just they find that so many things, how you manipulate audio data, it's a nuisance. There was never really a good tool for taking that data from where it lies on disk, maybe doing some transforms, maybe filter it out, maybe, you know, organize
so
it,
in
put
the
it in your
context
data loader.
in the context of what we're talking about in the Whisper data, you could take the audio and then kind of align it with the transcript using Lhotse. Is that what you're saying?
That is not what I'm saying. I would say Lhotse doesn't provide you those capabilities today. However, corpus creation tools are something on my mind. It's something that you would use ASR for. So maybe one of the other projects of the K2 ecosystem that Lhotse belongs to, Icefall actually has recipes for ASR models for training them, and how to actually do alignment. You could use that together with Lhotse, I believe, to achieve that goal.
Right. And so then the state of data processing in speech now with K2, Lhotse, and Icefall is what for an average data scientist? Much more accessible, much more fun, less painful.
That's quite accurate. That's quite accurate, actually. And it's definitely much more hackable. Like if you want to customize some of those things for whatever you are doing, it's much easier. Like before, let's go back 10 years. You had Kaldi. Kaldi was created around 2010. It's a speech recognition framework written in C++ and Bash and Perl. And it's a great tool. Like a lot of people use that in production. It's very, very performant, very stable, has great recipes. But today, just not many people, it's such a high barrier of entry. Not many people can leverage that, right? So that's where the idea was born. Hey, let's take all the lessons learned from there. Let's build a modern Python, PyTorch-based ecosystem of tools that help you deal with all those things, data, graphs for decoding in ASR, modeling neural networks, and so on.
So, Piotr, I take a big model like Whisper. So I think of it like a large language model, right? So Whisper is like my large language model. Now, in NLP, what happens is that you need to do fine tuning in order to actually use these language models in your domain. So now I take Whisper. Is Whisper also kind of in something like that where it's a general purpose thing, but if you actually want to use it in your very specific domain, you have to fine tune it, or they think of it more like, hey, we've trained it so that it's zero shot. You shouldn't have to do any fine tuning at all. So what's your sense of
All right. So based on what I see, the model actually works pretty well as an ASR and even speech translation out of the box. Like, since it saw so much diversity in the data, it was
even
afraid that
so let me map this to NLP. So in NLP, if you take if you go into a specific area in medicine, some specialized area in oncology or radiology or whatever, the general NLP model won't work as well.
Right. That's a really good point.
So then in this case, if I go into some specialty, like would it still work? But I guess the difference here is all it's doing is transcribing.
Yeah.
It's not doing any understanding, right? So
you could, that's an interesting claim. If you do the translation bit, I think some people would argue that some sort of understanding might need to happen inside of that. I don't think I would rather not dive into this discussion. I think
well, the reason I bring this fine-tuning up is I can imagine, if I take Whisper and I'm a hacker and I want to fine-tune it, fine-tuning means feeding it new data for my domain, which means probably using Lhotse to prepare that data to fine-tune it with.
You could definitely do that. That's something that Lhotse could definitely help you with. And yes, I believe for very specialized domains, you would probably need to fine-tune the model. That is right.
So what happens next? So the first thing that will happen, I predict, is there will be a stable Whisper. I mean, even though Whisper is open source and so on and so forth, someone will come up with something that's either easier to use or a copy of it or something, right? And then there will be Whisper 2. So what else can happen at this point in the world of ASR? And is ASR, how disruptive is Whisper to ASR?
All right, I would say it's a fairly significant event. Basically, everybody right now can download the model, and people are using it with great accuracy to transcribe whatever they have. Of course, the model sometimes will make mistakes, sometimes fails, but it mostly seems to just work. But I think there is one direction where it can really evolve. That is real-time transcription. The current model, it basically has to do like locally offline thing, like 30-second chunks or whatever. It's if you want to see the transcript right now, let's say live captions of this conversation, this is not the right model to use. You would not be able to use that unless you have some colossal GPU that's super fast or whatever. But one thing it can.
What's the transition from like a batch to a streaming model? Does that mean you compress the model, or so? What's the natural?
Not necessarily. It's about how much context the model is allowed to see. For example, if I want to have prediction within 100 milliseconds of what I'm saying, the model cannot look ahead more than 100 milliseconds minus the processing time, right? So it kind of has a limited context. It cannot see the future. And this is and the current version of Whisper, it does see the future.
I see. So, okay, so one natural avenue, as you point out, is kind of real-time transcription. What else can you imagine happens next?
Well, I can imagine they will expand to more tasks, right? Right now they tackled ASR and speech translation. They have language ID, but there are more tasks in the speech, speech community. There's emotion recognition. There's.
I'm surprised that you. So you don't think that? Okay, so now that we built Whisper, we just took transformers from 2017, but now that we have all this data, let's try to build an even more accurate version of Whisper. You think that's not a high priority?
No, I do think it is a priority. I don't know, to be honest. Sometimes I'm wondering because they have OpenAI, they have shown before that this transformer architecture, it's if you just have lots and tons of data, it just scales really well. I think it opens up a question of how much like domain-specific tweaking to the architecture you actually need, assuming you have unlimited data, infinite data, right?
So if you run a transcription service, what's
Yeah.
your reaction to Whisper? Do you say, hey, team, let's drop our model and shift over to Whisper? So what do you think is in the minds of people who are deploying transcription services?
On one hand, they might be a little bit concerned. On the other hand, you still often need to support like very specific, requests from your customers, very specific domains. I don't know. We talked about medical before, right?
All right.
So unless you have somebody that can take that Whisper model and adapt it for your domain and verify that it really works for that kind of thing, well, you cannot use it, right?
Right. So am I wrong? Because the demo I saw of Whisper was that it was transcribing something where the audio was being played like 4 or 5x faster than normal.
that was damn impressive.
So then does that mean though, Piotr, that at some level, Whisper doesn't care about accent? Because basically, if you can feed it audio and speed up the audio, then it obviously doesn't care, right?
Interesting question. Within the diversity it saw of accents in the training data, I'm sure that's true. I'm very curious if I'm sure there are some accents on this planet that were not seen in the training data of that model. And the interesting question is, would it still work? Would it truly generalize to that kind of data? I don't think we know that today.
And another thing that you and Yishai, the CEO of Meaning, have always pointed out to me is that ambient noise, right? So can this thing work if have my car window open?
I'm pretty sure it would work based on 680,000 hours of data. There's such huge diversity of acoustic conditions, like noises, bed mics, distortions, dogs barking in the background, everything. I think the model would handle that.
Right. And so then, who else is working, do you think, on this kind of massive amounts of data for transcription? Because this, as an outsider to the space, it seemed like this surprised people.
A little bit, yeah, I would say, yeah. The scale of data we see here is not something I have seen in, for example.
Because this is something you would expect Google or Facebook to do because they have access to consumer data.
They could. Right? Yeah, I would completely not be surprised if they tried, for example, self-supervised learning with those amounts of data. We all know they have the infrastructure to do that.
Right. No, I mean, for as far back as a few years ago, I was in a coffee shop with a good friend who whipped out one of these Google phones, and the coffee shop was loud, and he showed me how well it was transcribing our conversation in real time. Yeah, locally, offline, right? So he turned off the Wi-Fi, right? So
yeah. It's very impressive. I agree with that.
Yeah. And with that, thank you, Piotr. And once again, I'll link to our post on speech data processing. And if there's anything to take away from this episode, it's one thing: it's time to work on audio and speech data.
For sure. I encourage everybody to do that. The more, the merrier.
All right. Thank you.